Alright, ladies and gentlemen, in this video I'll be going over what is load balancing and why it's a must in distributed systems. Now, the reason why I'm making this and why it creates future system design videos is because currently I'm actually creating an application and I kind of had to review system design concepts, and I felt like the one that was beneficial to start off with is load balancing because it's used so widely in systems, right? Especially as systems start to grow. So let's go more in depth on what is load balancing. So like I said, what is load balancing? Well, load balancing is a way to help mitigate many requests by distributing the networks across multiple resources. So you guys use applications every single day, right? You may use Instagram, you may use YouTube, you may use, or you're on YouTube right now, right? Or you may use, different applications, right? And some of these applications have millions of requests that are made daily. Some are even made hourly, right? Things like Twitter, right? Twitter expect, millions of tweets every single week, every single month, and they have to be able to handle all of that traffic. So many different methods were made to help create a scalable system that can handle the workload and decrease the stress on systems. Now, originally, what was the thought process, right? You have a client and you have an application, you have a server, and that client makes a request to that server to receive or to attempt to receive a response from that server with the information that is needed. But like I said, you have an application like Twitter, which may receive millions of tweets. And does one server or is one server really enough for millions of tweets, especially simultaneous tweets? Probably not, right? You probably need multiple servers to handle that load because one server is definitely going to crash. I don't care how much money they spend on a single server, how many times they try to vertically scale it, is not going to be enough, right? It's going to crash eventually because that's just too much. Remember, you can upload videos, you can upload pictures, you can, upload text, which is, you just creating like a simple tweet. And all of that is probably going to be too much for a server. So a method to help mitigate that is load balancing. Like I said, load balancing is to help, mitigate many requests by distributing them across, or distributing the requests across multiple resources. So how does it work? I put it step by step to help you guys understand, right? So a client, like I said, that can be your phone, that could be a computer, right? A client will send out a request to try to communicate with a server, right? So the client sends us a request using, twitter.com or using whatever the name of the website is, right? And it goes into a DNS server. That DNS server returns an IP address, and that IP address will be pointed towards the server, right? But in our case, we're going to be using a load balancer, which, the IP of the load balancer will be used in, the DNS server, and that will take in the request that was sent by the client, right? So it receives the request, and based on the algorithm chosen for the balancer, which we'll talk about later in this video, it routes the request to one of the servers in the server group. And you can see that in the model below, right? You see a client send a request to the balancer, and then you see that there's 3 different servers, right? And each individual server has its own private IP. This is not accessible outside for the internet to use or for the internet to see. The only IP that the outside sees is the balancer's IP, but the private IP is internal. So the balancer is what routes the request to an IP that you could say in this case is not doing too many things, right? For the most part, it will try to send a request to the server that's doing little compared to the other servers, right? But there's different algorithms that can be, used to choose the proper server. Like I said, I'll discuss that later in this video, but for now, you can hypothetically say that it's choosing the server that is not doing too much work compared to the others. So then the server receives the request. It responds to the client using their load balancer. So like it takes in the request, it gets the information that is being requested, if it's a proper request, and then it sends it back to the balancer. The balancer then receives a response. It gets the IP of the client that made the request, and then it sends that response back to that client. Then the process is repeated over and over and over again until the end of time. No, I'm just joking. Until it's over, until the session is over, or until maybe the company goes down or whatever. But as long as that capability is there, it's going to keep doing it. So that's how the magic works. So what are the benefits of load balancing? The goal of load balancing is to reduce the workload across resources and to improve resource availability. Because if one resource is busy, we would want another server to pick it up that's not doing as much, and that would better provide, better functionality, better responsiveness, which is better for whoever is using the application. But the load balancing also comes with a lot more benefits, which includes improved efficiency, right? Because like I said, if one server is busy, the response may be slower. We don't want that. We want to lessen the load, and we want to make sure that it's a smooth operation and response times are as minimal as possible to give a better experience. It's resilient, which means that there's little to no downtime, or that's the goal, because any defective or underperforming resources can probably be replaced with a server that is working properly. So if a server fails, then the request could be rerouted to another server that is working. Then there's scalability, right? A load balancer allows you to change the server infrastructure at any time without impacting any other service. So say for instance we had to bring down a server, right? We could just route it to another server that is running, make changes to that server and bring it back up and route it back. So in the case that maybe you have an influx of users or increased amount of users, or if you want to make any changes internally, you can do that without having to worry about it. And then there is predictive analysis, which there are some load balancing softwares that enable predictive traffic load, so that it can see that, okay, at 1 p.m. you usually have about 1,000 users, but at 12 a.m. you usually have about 10, right? So we'll adjust the balancer because of the fact that we know you have more traffic at this time compared to another. There is analysis being done, and that's a software that's offered with load balancing. So I talked about it a little bit before when I gave the step-by-step analysis of how it works, but load balancing comes with many different algorithms, right? So the request can be received by all types of load balancers, right? And each one of these are algorithms that come pre-configured when creating your load balancer. So the first thing is the least connection algorithm, which traffic is routed to the server with the least amount of traffic, right? It makes a lot of sense. Why would we want to route request to the server that's already handling so many, right? We want to route the request to the server with the least amount of traffic. So this ensures that it keeps up a great performance, especially during peak times, by ensuring that all servers are loaded evenly or as evenly as possible. Then you have weighted least connection. So each server is assigned a different weight based on the hardware. So some servers may have more CPU or more memory. So each server is given a weight, and based on that weight, it has the ability to handle more connection than others. So that is weighted least connection. So based on the weights and based on the amount of connections, then the request will be distributed to the proper server. Then there's weighted response time. By sending traffic to the servers with the quickest response time, this will allow for the algorithm to ensure that the service is faster for users. So instead of it going by, the amount of traffic, it just goes by the average response time. So then there's resource based. So that means that requests are distributed based on the resources that each server has available. So if it sees that a server CPU and memory is less than another server's, or less than the other servers, then the request will be routed to that server. Then there's round robin, which distributes traffic to a list of servers in rotation. So, one server might get it this round, then the second server might get another round, and it just rotates. And then there's IP hash, which is, the one that I learned first, which it combines incoming traffic source and destinations by IP address. So it uses a mathematical function to convert the IP and the destination IPs into a hash, and then based on the hash, the connection is assigned to a specific server. So it's based on the function's hash output that would let the load balancer know which server is going to receive that request. So each algorithm, tries its best to be as efficient as possible. But all of this is pre-configured, and algorithm can be chosen based on what fits your system. So that's research that can be done on your end, but there are so many algorithms that can be chosen for your system. So in summary, a load balancer is just a piece of the puzzle to help your system scale and be as efficient as possible. As I read through all these algorithms, you just have to choose the one that best fits your server. But at the end of the day, each algorithm is trying to be as efficient as possible. A load balancer can be used to make sure that an engineer can sleep better at night. Trust me, I know. We want to make sure that we don't have to do this all manually. We want to make sure that you have a system in place that can do that for you. Because as a person that's building an application, you want to make sure that whoever's using the application has no problem when it comes to response time. We don't want to have to wait double the amount of time because you're only using one server. We want to make sure that it's distributed properly and that the response times are as minimal as possible. So make sure that that is a priority, and make sure that if you want to become different from your competitors, that you make a system that is efficient and runs smoothly. So I hope you guys enjoy that. Hope you guys find that educational. And if you have any questions, don't be afraid to leave that down in the comment section. I hope you guys enjoy that. Leave a like, subscribe, and I intend on doing more system design concepts. So thanks for watching.